Hey, what's going on guys? My name is Madison Jonathan from MLC Tech, and now the AI boom is in full swing at the moment and manufacturers are bringing new advanced memory technologies to the table. With Samsung and Micron currently preparing their entry into the next generation of high bandwidth memory, that be HBM3E. And this newest version of this DRAM technology is set to bring significant increases in both bandwidth and capacity, with Samsung and Micron leading the charge in the industry. Now, despite entering the market somewhat belatedly, Samsung is introducing its HBM3E 12H DRAM chips as a pioneering achievement in 3D layered memory technology. The latest memory chips from Samsung will utilize a novel 12-layered stack which can deliver a 50% increase in both performance and capacity compared to HBM3E chips that only feature an 8-layer stack. Now, these 12H chips can achieve up to 1,280 gigabytes per second of bandwidth, and Samsung are claiming that this is providing an unprecedented capacity of 36 gigabytes. And that is very impressive, as that is 36 gigabytes per single module stack. Now, Samsung has managed to stack 12 layers in the same chip by utilizing advanced thermal compression non-conductive film, referred to as the acronym TCNCF. And this appears to maintain the same height specifications as 8-layer chips, meeting current requirements for HBM memory packaging applications. So the fact we're getting a higher memory density in the same package size is great to see. Also, it offers additional benefits by achieving the smallest gaps between chips in the industry, with the gap between layers coming in at just 7 micrometers, while also reducing voids between layers. Vertical DRAM density can be increased by 20% compared to HBM3E 8H chips. Improvements in manufacturing also provide better film properties and a higher production yield, as we are told by Samsung. And Samsung claims the latest version of HBM will provide an optimal solution for AI accelerators with a growing demand for DRAM memory. In comparison to the original 8-layer HBM3 chips, Samsung claims that the new 12-layer stack is set to offer a 34% increase in average speed for AI model training. Now, Samsung is currently providing its first samples of its HBM3 12-layer chips to select customers, with mass production expected to begin in the first half of 2024. But taking a look at the other player in the HBM3E market, that being Micron, they have also announced a full-scale production of its 3D memory chips, with Micron doubling down on the traditional 8-layer design of HBM3. However, despite Micron sticking with the 8-layer approach, they seem to got into Nvidia's good books, with Micron set to supply Nvidia with 24 gigabytes of 8H HBM3 chips for the upcoming H200 Tensor Core GPU, which is a powerful AI accelerator set to hit the market in the second half of 2024. Similar to Samsung, Micron is positioning its HBM3E technology as a leading solution for memory-intensive applications and generative AI services. It's currently unknown what memory solution is going to be used on Nvidia's upcoming line of Blackwell GPUs, that be the RTX 5000 and also their B100 and B200 range of AI accelerator cards. Though it's rumoured that these could potentially feature the latest generation of HBM3 from SK Hynix, or could potentially see the debut of HBM4. Other sources have potentially claimed that they could switch over to GDDR7, though that remains to be seen how well that memory technology performs. With GDDR7 set to be 20% more efficient compared to HBM3E and offer more bandwidth and a higher pin speed as well. But currently, HBM3E chips offer a pin speed greater of 9.2 gigabits per second, providing over 1.2 terabytes per second of memory bandwidth. The company states the power consumption is 30% lower than competing products, and the 24 gigabyte capacity enables data center operators to achieve seamless scalability for extensive AI applications. And Micron's Executive VP and Chief Business Officer, Sumit Sadana, highlights that the company's new HBM3 chips can support business growth and the surging demand for AI. But looking ahead to the future, Micron is also preparing 36GB 12-layer HBM3 chips also later this year as well. So it's very interesting to see the direction that the memory landscape is shaping up to be. It's going to be very competitive for all of these different types of solutions, especially when it comes to the more higher AI market, where the use case for HBM has become very appealing for a lot of these AI data center customers. However, the cost to produce HBM3 is so expensive still that we're never going to see this pop up on consumer level cards anytime soon. Now, it makes sense they can get away with using this memory on the higher end data center cards, where they're charging tens of thousands of dollars for a single GPU. Of course, they have the money to implement this higher cost memory, but I'm still hopeful for the future that eventually this type of technology will trickle down to us normal consumers so we can get it on potentially a consumer level card. Though at the moment GDR7 looks like the memory to take that spot in the coming future. But seeing the advancements in all these types of memory technologies is still super exciting for me, despite the likelihood that I will never have the chance to experience it on a product myself. I still really love the direction that technology and memory is shaping up to take. Anyway, that's going to be it for today's video. Let me know all your thoughts and opinions on the story in the comments down below. What do you think of HBM3 chips being used in data center and AI GPUs? And do you think this technology will ever trickle down to the consumer market? Let me know all your thoughts around this in the comments down below. Anyway, I have been Madison Charlton from MLC Tech. Thank you so much for watching today's video. If you liked it in any way, shape or form, make sure to give this video a like and maybe subscribe for more content like this in the future. Thank you once again for watching today's video, and I hope to see you in another one soon. Goodbye for now.